Okay. So first of all, any problem with the questions? Can do, cannot do? I need to know. Any problem with the question? Okay, this is chapter 3. January 2007. Okay, sure. January 2007. Let's see. Okay. Okay. Oh, yeah. This one you don't know how to do yet because of there is a uniform distribution there that we're going to discuss today. Okay. There is a uniform distribution here that we're going to discuss today. Okay. But never mind. This one. Oh no, cannot. This one we haven't tackled this yet. This uniform distribution, continuous uniform. We're going to discuss it today. Okay. Eight. Two other person. James, Bruce, Brian is here. Okay. Okay. Since we can, I will continue with the new sections. Okay. Continue with the new section, which is previously you already learned about general continuous distribution. Okay, you already know some rules. So you have a shape. Okay, then you have this is your fx. Okay, then you can actually change into a capital F. Okay, then you have the mean. Okay, which is integrate of x, fx dx. You have your mode. You have your median. Okay, you have a Q1, Q3. You have answer about skewness. Okay, so we already did all of that. Okay, now we're talking about special continuous. Okay, special continuous. So over here we are talking about continuous uniform. Continuous uniform distribution. Okay, so the idea is this. Now you have a string. Okay, you have a string. If you measure it, okay, there is a length of a 0 to a certain length. Okay, maybe k cm long. So you have a scissor. Okay, you have a scissor. You can actually cut at anywhere along the line. You can cut here, 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 you can cut anywhere. Okay, so what is the probability the length that you cut, the place that you cut is a fulfill a certain length. Okay, fulfill a certain length. This is continuous uniform distribution. So there all of them actually have an equal chance to actually cut it. So over here we say X is continuous uniform with AB, where this is your X, this is your location of A and the B. Okay, you have an equal chance to cut anywhere with 1 over B minus A. The total area underneath is 1. Can you understand?
Yes.
Okay. So therefore, from here, since it can be the value is 1 over b minus a, therefore your PDF will be 1 over, we'll write it like this, 1 over b minus a for any value of a, x to be 0 otherwise. Okay, we can actually write in this form. Can you do a quick calculation and tell me what should be the capital F look like? How should be a capital X look like? Very, very easy. Very, very easy. How should be the capital X look like?
Is it just 1 over b minus ax?
1 over b minus ax. That one is differentiated, but you haven't substituted the value in.
Oh,
The
okay.
smaller value is a. So of course we have 0 and 1 for x lesser than a, for x greater than b. So what we need to identify is what do we have in between. It will be fulfilled x minus a over b minus a. Why is it like that? Because at a certain point x here, the area that accumulated is only up to this area with the length of x, the width of x minus a, and the height of 1 over b minus a. So width times height, that's what we have this. Can you understand?
Yep.
Okay, of course you can actually use the integration to figure it out, and by using the integration you also get this as a result. Okay, so because of the setting here over here, what can we comment about mode for these continuous uniform questions?
No mode.
No mode, very good, no mode. What can we say about mean? Oh, not mean, yes.
No mean.
There is a mean. Okay, but
Oh, is it the
median,
middle?
it is in the middle. The median, what about the median?
Is it just a plus b over 2?
A plus b over 2. The mean and the median, it will be the same value, a plus b over 2. Of course, the mean will be, you can actually do it by using proving method. So expected of x equals to integrate from a to b. Okay, x when 1 over b minus a dx. So you have a 1 over b minus a integrated, you have x squared over 2 of b over a. Okay, substitute things inside. So you have a b squared minus a squared over 2 of b minus a. Can you see how can we simplify this? Can you notice how do we simplify this?
Oh, yeah, it's just b plus a over 2.
Yes, it's just b plus a over 2, right? Because of the factorization, b minus a, b plus a, difference of 2 square. So we have a plus b over 2. This is why it's true. Okay, so we have no mean, median, mode. So how do we identify Q1? Also very easy.
A plus b over 4?
A plus b over 4. Not very good.
Oh, wait. A plus b minus a over 4. Wait, no, that's wrong.
Of course, you can. The rest of the students, you can actually see that the Q1 here is something that can be obtained purely by logical thinking. Why do I say that? Because it's a rectangle with a height of 1 over b minus a, and your Q1 is over here, your a is over here, the area that you need is 1 over 4. This is why it is something that we can actually identify it logically by using critical thinking. So you will see that q1 minus a times by 1 over b minus a equals to 1 over 4. So q1 is 1 over 4 b minus a plus a. Get it? Can?
Yep.
So by using the same structure, what can we say about the Q3?
3 over 4 b minus a plus a.
Okay, so as you can see, it's purely by logical thinking. Okay, so the hard part is the variance. The harder part is not very difficult anyway. Okay, the harder part is actually the variance. That actually we need the ex square minus ex, the whole thing square. So the ex is we have a plus b over 2. Okay, so what you need to figure out is what is exactly ex squared. So please calculate ex squared first. Tell me what you get.
It's negative bracket a square plus ab plus b squared.
Why there is a negative? You didn't simplify it?
Hmm?
You didn't simplify it?
Simplify. I'm not so sure. Let me think.
Is it b square minus a square over 3?
B square minus a square over 3. Okay. Anything missing? A. B square minus a square over 3. Why is it square? You shouldn't have a square. It should be power 3.
Oh, is it like wrong factorization?
Is b cubed minus a cubed divided by 3 bracket b minus a, right?
Yeah, that's what I got to.
B cube
Minus a cubed
hmm,
over 3
hmm,
bracket b
hmm.
minus a. Then we can simplify it to negative bracket a square plus b square plus
The
ab.
bottom. This b square, b minus a is actually at the bottom. Sorry.
Then b cubed minus a cubed is equal to negative bracket a minus b bracket a square plus b square plus ab.
So it's a factorization. So over
Yeah.
here, you actually get b cube minus a cube over 3b minus a. Then this one over here, you have a plus b over 2, the whole thing square. The bottom over here, okay, this one, you can actually simplify factorization, okay, difference of cube. So you have b minus a, the whole b square plus ab plus a square. Still remember this from your algebra? So this and this will be cancelled off. Then we simplify the thing. We have 1 over 12 here. So 4b squared plus 4ab plus 4a squared minus 3a squared minus 6ab minus 3b squared. We have 1 over 12 of b squared. Then minus 2ab plus a squared. So you have a b minus a, the whole thing square over 12. Here's your answer. Sorry, right now my mind cannot think straight because hungry already. Are you okay? Can you understand? Okay, so this is one special type that you need to know. Okay, and we already seen the properties for the continuous uniform. So back to the January 2007 questions. Okay, that one is actually a continuous questions. Okay, a combination of 2 or more distribution. We can actually let's look at that questions. Okay, so it's just that they write in the form of alpha beta instead of AB. The continuous random variable x is uniformly distributed over an interval of alpha beta. So x here is continuous distributed with alpha beta. So this is how we write our distribution. Okay, this is how we write our distribution. Write down the probability density functions. Okay, A. So the PDF fx equals to 1 over beta minus alpha. So for alpha, x is in beta, so 0 otherwise. Okay. Then given that ex equals to 2, this equals to 5 over 8. So b here, ex equals to 2. This actually tells us that alpha plus beta over 2. So 4 equals to alpha plus beta. And the second information is p of x lesser than 3 equals to 5 over 8. This one tells us that 3 minus alpha over beta minus alpha equals to 5 over 8. Why I actually can write like that is because of CDF here. It's because of CDF here. So I can write immediately. Okay, so I will have 24 minus 8 alpha equals to 5 beta minus 5 alpha. So you can see it's actually a simultaneous equation question. So I will have this one bring over 3 alpha plus 5 beta equals to 24. So equation 1, equation 2. So press calculator. Simultaneous equation, 2 unknowns. Okay, 1 equal 1 equal 4 equal 3 equal 5 equal 24 equal. So your alpha equals to negative 2. Your beta is 6. Okay, so we have managed to find the value of alpha and beta here. Okay. A gardener has wire cutter a piece of wire of 150 meters cm long, has a ring attached at one end. The gardener cut the wire at random chosen point into two pieces. The length of the pieces of wire with the ring on it represented by the random variable x. Okay. So what does it x actually means over here? Has a wire cutter and a piece of wire 150 meter cm long, 0 to 150. It has a ring attached to one end. Okay, so the gardener cut the wire at a random chosen point into two pieces. So cut. Okay, the length in cm of the pieces of wire with the ring on it. So the ring is over here, representing by x. So this is your x. So this is, so therefore you can see that the x can be anywhere in between 0 to 150. Okay, so x is a continuous uniform of 0 to 150. Therefore, C, to answer this question, is 0 plus 150 over 2. So you have a 75. Then standard deviation, D. Okay, so we calculate by the variance first. That actually give me b minus a the whole thing square over 12. So I'll have a 150 minus 0 the whole thing square over 12. So 150 square over 12. So your standard deviation will be square root of 150 square over 12. So it's 150 over square root 12. Of course, you can simplify it if you want to. Then the D, the E, the probability that the shorter pieces is at most 30 cm long. Okay, so when you do the cutting, it can be here that being short, it can be here that being long, it can be also the other way around. It can be here that being short, that here that being long. Therefore, it could be two pieces. Okay, two situations. The probability that the probability that shorter is at most 30 cm. Okay, it's actually 2 times of p of x lesser equals to 30. Because it can be this or this. It could be on the left side or it could be on the right side. So this 30 here will be 30 minus 0 over 150. Okay, so 60 over 150. Okay, divided by 3, 2 over 5. That's your answer. So can you understand the difference of it? How does it work?
Yes.
Okay, then let me try to look at more some of the challenging questions. Okay. Okay, so right now I'm looking at the continuous uniform. So the continuous random variable L representing an error in mm made by a machine cut road to a target length. The distribution L is a continuous uniform over the interval of this. So L is continuous uniform of -4 to 4. Okay, so for A, for PL lesser than -2.6, which is the same as -2.6 minus -4 over 4 minus -4. So you can see that I just applied the CDF formula. Okay, so I will have over here fraction 4 minus 2.6 over 8. So I will have 0.175. Okay, then B, for P of L lesser than negative 3.0 or L greater than 3.0. So you can actually calculate, you can calculate them separately, or you can actually calculate them together. Okay, task time, just calculate one side. So if let's say I calculate them separately, I have negative 3.0 minus of negative 4 over 4 minus minus 4. Okay, it plus this one greater than 4, so it will be 4 minus 3 over 4 minus negative 4. So I have 1 over 8 plus 1 over 8 is a 1 over 4. Okay, then after that, there is a continuous questions. Okay, this is a combined questions. A combined questions. A random sample of 20 roads cut by the machine was checked. Okay, find the probability that more than half of them were within 3 millimeter of the target length. Within. Okay, within. So this one now they change from continuous to binomial. Okay, so y here is number of road within 3.0 mm. Okay, so y is binomial distributed with 20. Anyone can tell me the p-value? The probability of success value. Anyone? Anyone can?
Is it 3 over 4?
Very good. Okay, it is 3 over 4 because the top part already helped you to sort out the questions, the answer. Oh, so this is the 3 over 4. So students need to know whether the information is actually related or not. Okay, so over here within 3.0 mm is actually the complement of this, the question from B. Therefore over here, okay, more than half. Okay, now they say more than half. Why more than half? More than 10. Okay, so I will have P of y equals to 11 plus P of y equals to 12 all the way to P of y equals to 20. This one, how do we actually calculate this in the fast way using binomial? Anyone? Anyone? Binomial. Anyone? Anyone? Hello. If you don't remember, you just can tell me you don't remember. Or did I actually lost connection?
Wait, Mr. Sam, this is the 20C11.
Yes, correct. That's why I,
20
that's why I'm asking, how do we actually do it in the fast way?
calculator,
How?
binomial CD.
Binomial CD. Okay. What should I write for the next line? What should I write for the next line?
P of y, 1 minus P of y is lesser than equal to 10.
Very good. Okay. So then press calculator. Give me the number. Tell me what number do you get?
0.01386.
Okay. Then you subtract it. Yes. 0.986. That's your answer. Okay. That will be how you do it. So the thing will be, are you able to do the calculations? Get it? Okay. Let me try to find something. The other example of combination of two or more distribution. No, no. Okay, this one. Okay, let's see. Jin regularly take a break from work to go to the post office. The amount of time Jin waits in the queue to be served at the post office has a continuous uniform distribution of 0 to 10 minutes. Okay, so X representing the time. So CU with 0 to 10. Find the mean and variance. Okay, so we find the mean and variance. So mean equals to 10 over 2 equals to 5. Variance equals to 10 squared minus 0 squared over 12. So it's a 100 over 12. Okay, simplify it if you need to. Then B, find the probability that Jane does not have to wait more than 2 minutes. That does not have to wait more than 2 minutes. This is the part that students always having problem. They have no idea whether to write more than or less than. What do you think?
Less than, less than 2. Less than 2 only.
Less than 2? Got equal sign or not?
No, more than 2 minutes. Oh, God.
Yes. So this is the time this is when usually a lot of students having problem to actually translate the sentence into mathematics, especially students who are not so strong with English. That's a common problem. So, but it's a common problem to be solved. Okay. So over here, I will have 10 minus 2. Oh, sorry, not 10 minus 2. 2 minus 0. And 10 minus 0. So you have a 1 over 5. Okay. Okay, next. Jane visit the post 5 times. Okay, post office 5 times. Find the probability that she never has to wait more than 2 minutes. So it's a continuous question. Okay, combinations of distribution. Okay, so I have a y that representing no need to wait more than 2 minutes. Number of times. Okay, number of times, sorry. So y is binomial with 5 times and 0.2. Never So P of y equals to 0. So I will have never have to wait more than, does not have to wait more than 2. I'll never have to wait more than 2. Never has to wait more than 2 is always wait more than 2. So this is 0, correct? Okay. So you have a 5 choose 0. Okay, 0 0.20, 0 0.8 power 5. So the answer is 0 0.8 power 5. Simplify if you need to. Okay, next, Jean is in the queue when she received a message that she must go return to work for an urgent meeting. She can only wait in the queue for a further 3 minutes. Given that Jane has already been queuing for 5 minutes, so P of this is a given, therefore it's a conditional probability. Okay, this is a conditional probability. Further 3 minutes. Further 3 minutes given past 5 minutes. Okay, find the probability that she must leave the post queue without being served. Okay, without being served. So that means without being served. Without being served means okay, can only wait for further 3 minutes. Okay, so that means have to wait for further 8 minutes. Okay, probability that this one x lesser than 8 given that x more than 5. So P of this one 5 lesser than x lesser than 5 over P of x more than 5 for conditional probability intercept. So I will have a 8 minus 5 over 10 on top and 10 minus 5 over 10 below. So I have 3 over 5. How to actually explain to you this way? Let me see. How should I explain this to you?
Is it the probability of her being served on the 6th and 7th minute, given that she has been waiting 5 minutes?
Yes.
Wait, Mr. Sam, how come for C we only show when it's equal to 0?
For C, because it says never. Never has to wait for.
Wait, Mr. Sam, why don't we include 8 for D? Like Px is smaller than or equal to.
So you are referring to C or D?
Oh, D.
D, again, your question?
Oh, why don't we include 8?
Oh, we can include 8, of course. Wait, this one, without being served. Next, waiting for next 3 minutes this is still able to serve. So without being served is actually alternative of this. So without probability of not serving, not serve, should be 1 minus 3 over 5. So we 2 over 5. Or alternatively, we can do P of x greater than 8 given x greater than 5. Probability of x greater than 8, probability of x greater than 5. 10 minus 8 over 10 over 10 minus 5 over 10. So will be 2 over 5. 2 over 5, correct. 2 over 5, yes, correct.
Wait, Mr. Sam, for C, shouldn't we also count when it's equal to 1 and 2?
Okay, look at so question C. Look at the questions. Visited for 5 times. Okay, never have to wait more than 2 minutes. The Y is the number of times. No need to wait for more than 2 minutes. Y representing number of times. No need to wait for more than 2 minutes. The probability not need to wait for 2 minutes is 0.2.
Oh, okay. I understand it now.
You can see that the nature of the statistics here, the for each topic is actually very little. It's just that how complex we can actually ask the questions. Okay. Is it better now? I think I'll send you this work. Okay, so you can actually process it. I know that within 1 week there are so many things to absorb. It's actually quite tiring. Okay, but I hope that you actually spend your time properly. Okay, and try to absorb, because we are, honestly speaking, we are behind time. We still have 2 chapters for S2 for information. The remaining 2 chapters are concept questions. Okay, there will be concepts. Okay, I'll stop recording now.